Hey guys, Miss Miklos here, and today we are going to dive into Chapter 6, Section 2, and we're going to talk about law of cosines. And some of you guys may be wondering, well, why do we need to know this other law? And so a quick thing for me, normally when we are talking about two different angles, and that could be that we know two angles or we know one angle and we're finding a second angle, that's when we use law of sines. However, what we're going to see today is that we're going to be given a different set of information. So the set of information we're going to see today is going to deal with one angle. So it could be that we know all the sides and we're finding one angle. It could be we know two sides and one angle. And in these cases, we are going to use our new law for the day, which is called the law of cosines. So our formula for law of cosines is c squared equals a squared plus b squared, that should look pretty familiar, minus 2ab cosine of angle C. Now, just like with law of sines, just because we're using side C and angle C, that doesn't mean we need to use those specific angle and side. What matters is that these angle and sides are the same letter, that they are opposite from each other. So I'm going to just write that it should be the same. Okay, so it's telling us to round our answers to the nearest tenth, and if we look at number 1, it says given a triangle with side A, angle B, and side C, find side B. So notice in this case, we're only talking about one angle. So would it be possible to find side B using law of cosines? Law of sines? And the answer is no. Okay, we don't have enough information to do that. So that's why law of cosines becomes important. Since I'm dealing with angle B, that means that I need to put side B all by itself. So if I have b squared equals a squared plus c squared minus 2ac, there we go, cosine of angle B. And once again, I normally just write in that info until I have that formula memorized. Once I substitute values in here, I get b squared equals 2,178 squared plus 1,719 squared minus 2 times 2,178 times 1,719 times the cosine of 23 degrees. So first thing, we need to make sure that our mode is in degrees because this is in degrees. Secondly, in order to solve this, I noticed that what I need to solve for is almost isolated. Okay, in fact, I can put all of this into my calculator right away. So I'm going to go ahead and do that right now. So I get b squared equals 805,937.7955. And now I need to square root that. So I can go ahead and do square root and then use second answer, that is our second negative, just so that it keeps this entire value exact. We never want to round until our final answer. So when I square root this, I get b equals 897.7. Now, the other thing we could have done, in our calculator, we could have done the square root and then typed this entire expression in, and it would just give us 897.7 right away. Okay, number 2, we have this degree minute thing again, but more importantly, they're giving us angle A. We need to, and sides B and C, we need to find side A. I'm going to convert this, and just to remind us, this is like 20 over 60. So I end up getting that this is 58.3 degrees. Since we're finding side A, I'm going to write a squared equals b squared plus c squared minus 2BC times the cosine of angle A. So I have A squared equals 23 squared plus 18 squared minus 2 times 23 times 18 times the cosine of 58.3 degrees. Okay, and just like we did previously, we can type that into our calculator, and then when we square root that value, I end up getting 20.4. And if we look at this, this answer seems pretty reasonable because angle A is kind of a medium-sized angle, so it might make sense that it's not the biggest angle, which is going to be B, or the smallest angle, which is going to be C. So the side length looks like it should be between those. Okay, number 3 is a little bit different. This time they're giving us all 3 sides and we're trying to find an angle. So once again, notice this is a time when we're only dealing with one angle. Since I'm trying to find angle C, I need to put side C all by itself. So I'm going to go ahead and write out the formula there. And now I'm going to substitute in the information that we know. So I'm substituting in those 3 side lengths. And then 2 times 80 times 51 times the cosine of just kidding. It's not of 113, that's what we don't know. So I'm going to put cosine of angle C. And if we look at this problem, there's actually 3 distinct parts to it. Okay, I have my 113 squared, then I have my numbers, which I can just simplify, and I have this giant term, and the reason why I cannot combine these values is because this is connected to cosine of angle C. So I'm going to have to do a little bit more work here, and I get 12769 equals 9001 minus 8160 cosine of angle C. So I went ahead and did those 3 parts separately in my calculator. Now I know that my goal is to somehow get cosine of angle C by itself. So I'm going to start by subtracting 9001 from both sides. So I get 3768 equals negative 8160 cosine of angle C. Now to get cosine of C by itself, I'm going to have to go ahead and divide both sides by negative 8160. And we know that when we are finding an angle, we need to use cosine inverse or sine inverse. In this case, it's cosine because it is cosine. And I'm going to do 3678 divided by negative 8160. And I get that angle C is 117.5 degrees. Now, that makes sense to me because I know angle C should be the biggest angle because it's opposite from the biggest side. The other thing that I want to point out, and we don't need to know this, but it would make sense that angle C is bigger than 90 degrees because the ratio of cosine was negative. And if we think back to last semester, we learned in quadrant 1, all trig functions are positive. In quadrant 2, only sine is positive. So if I see that we have a negative ratio, that tells me that that angle should be in quadrant 2. Now, we definitely don't need to know that. That's extra info, but thought you might find it interesting. Okay, number 4 is pretty similar. It's saying we have sides A, B, and C, find angle B. So I know that I need to put side B all by itself. So I'm going to say B squared equals A squared plus C squared minus 2AC cosine of angle B. So I'm going to go ahead and substitute in those values. And I would suggest that maybe you go ahead and pause the video at this point and go ahead and do this on your own and kind of see if you get the same answer that I do. So I'm going to go ahead and do these three parts separately. Square 230, I get 52,900. 117 squared plus 185 squared is 47,914. And negative 2 times 17 times 185 is 43,290. So just a reminder, at this point, I cannot combine these two values, which is the most common mistake to make. And that's because these are not like terms. So I'm going to subtract 47,914 from both sides. So I have 4, it might help if I was writing in a pen instead of a laser. 4986 equals negative 43290 cosine of angle B. I'm going to divide both sides. And I'm going to do cosine inverse in my calculator. And I'm doing 4986, sorry, my phone's going off, divided by negative 43290. And I get that angle B is 96.6 degrees. And once again, that would make sense that angle B is the biggest angle because I can see from those three sides that side B is the biggest. So honestly, guys, it doesn't really get much tougher than this. What we're going to see on the next few examples is that they're asking us to solve for the whole triangle. So the difference that's going to happen here is obviously we're finding more, but we also have some options as to what we can use. We can sometimes use either the law of cosines or the law of sines, and it's really up to you. So looking at number 5, they give us sides A and C and angle B, and it tells us to solve the triangle. So right now, we only have one angle, and we don't have the side opposite that. So our first step is going to have to be using law of cosines. So I'm going to do b squared equals a squared plus c squared minus 2ac cosine of angle B. So b squared equals 12 squared plus 21 squared minus 2 times 12 times 21 times the cosine of 72 degrees. So when I put this all in and square root it, I get that B is equal to 20.7. So now we know all three sides of the triangle, so we need to find our other two angles. And one thing of caution that I want to stress to you guys is this is when our answers may vary slightly. Since we are dealing with rounded values in our formulas, sometimes we will get slightly different answers. So it's super important that we show all of our work. Okay, I'm going to find angle A first, and if I want, I could use law of cosines because we know all three sides. However, I actually think that using law of sines is a little bit easier. So I'm going to go ahead and set up my ratio. And when I cross multiply and divide, I get sine of angle A equals 12 times the sine of 72 degrees divided by 20.7. When I put this into my calculator and do sine inverse, I end up getting that angle A is 45, so I'm going to say 0.5 degrees. Now, the nice thing is once I know two of the angles, I know that I'm always going to find the third angle by using triangle sum theorem. So this can save us a ton of time, but it is really important for you guys to always check that your three angles add up to be 180. So I end up getting that angle C is 74.5 degrees. Now, sometimes if you find angle C first, you might get something like 74.6 degrees or something slightly different. Okay, and then our angle A would have to be different as well. So I really need to make sure all three angles add up to be 180. Okay, number 6 is similar. It's asking us to solve for the triangle. And once again, with the information given, I have to find side A first. So I'm going to say A squared equals, and I'm going to skip that step and just substitute straight in. So I'm just writing all this stuff in there. And now I'm going to go ahead and put this in my calculator. And when I put that in, I end up getting something like A squared equals 4,045. When I square root both sides, I get A equals 63.6. So now I know all three sides, and I'm going to go ahead and find one of our angles. And once again, if you guys want to use law of cosines to find the angle, totally fine. It's really open-ended. I'm going to use law of sines again, though. So I'm going to do 63.6 over the sine of 23 degrees, and I like order, so I'm going to find B first, but for all you rebels out there, go for C. When I cross multiply and divide, I get 37 times the sine of 23 degrees over 63.6 equals the sine of angle B. So once again, I'm going to have to use sine inverse in my calculator, and I'm going to type that in as I talk to you. So sine inverse times, sine inverse of 37 times the sine of 23. We need to remember to close that parenthesis, divided by 63.6. And when I put that in, I get that angle B is 13.1 degrees. And that seems kind of strange, but if we look at these three sides, it would make sense that angle B would be smaller because side B is the smallest side. Now, last but not least, we need to find angle C. I know all three angles add up to be 180, so I'm going to do 180 minus 23 minus 13.1, and I end up getting 143.9 degrees. It would make sense that angle C is the biggest because side C is the biggest. Okay, number 7, it's asking us to find area, but this is very different from the area we did in our last lecture because they're just giving us three sides. So we're going to have to learn a new formula here. So this is a formula we call Heron's formula. The area is equal to the square root of S times S minus A times S minus B times S minus C. S is what we call a semi-perimeter. And the way we find a semi-perimeter is actually exactly like it sounds. Okay, I know perimeters when I add all three sides together, and semi would be half of it. And some of you may prefer to use law of cosines to find some information so we can use that other area formula that we've learned previously, and that's totally fine. I just want to show us this other option. Okay, so I have 80, 90, and 110. So the first thing I'm going to do is find what the semi-perimeter is. So I'm going to add all three of these sides together and divide by 2. And I end up getting 140. So to find the area, it's going to be the square root of 140 times 140 minus 80 times 140 minus 90 times 140 minus 110. And I actually think it's easier if we do some of this work on our own. So I get 140 times 60 times 50 times 30. And now I'm going to go ahead and put that into the calculator. And even though I use parentheses to denote multiplication, whenever I put stuff in the calculator, I always use times. Just because I think it's easier, and don't we all want to do what's easiest when it comes to math? So when I put this in, I get K equals 3,549.6 square units. And it's important that we pay attention to what the directions are asking us to do. Sometimes with area, we'll see that it asks us to find the nearest whole unit. And in this case, we would say it's 3,550. So we just need to pay attention to the directions. Honestly, Heron's formula doesn't get much tougher than that. And we're going to go ahead and use it one more time. So once again, they're giving us all three sides. So we're going to start here by finding the semi-perimeter. So I'm going to add 121 and plus 82 plus 90 and divide that by 2. Now, quite honestly, the one thing that's going to make this a little bit tougher is the fact that we're going to be dealing with some fractions here. Or decimals. If we do a decimal, that's fine. I get 146.5, and I'm going to leave it like that. So I have k equals the square root of 146.5. And now that you guys have kind of seen this in action, I'm going to use some shortcuts on this one. So I'm going to do 146.5 minus 121, which is 25.5. So I'm going to go ahead and put that straight into the formula like that. 146.5 minus 82, which is 64.5. And then lastly, 146.5 minus 90, which is 56.5. So now I'm going to put this straight into my calculator. So the square root of 146.5 times 25.5. Hold up, I forgot the times there. Okay, 25.5 times 64.5 times 56.5. And when I put that all into our calculator, we end up getting 3,689.7 square units. So the homework quiz and the suggested problems that go along with this section all deal with using law of sines and law of cosines. The final thing we're going to do with it will be in the next lecture, and that is using the application of it to solve some real life problems.